Hello, everyone. This is John Yoon. I'm going to introduce to you the mobile technology, the encryption of mobile technology, and how the cybersecurity can protect your data that transmitting between your mobile device and remote servers. Project was the blockchain approach to protection and detection of application programming interface data transmission. This poster is very crowded. My video presentation will be detailed out in this way. So I'm going to start with the motivating examples, and there may be typical approaches, and also I are proposing my approach, and then some of the research result with the conclusions. Here's your mobile device. A mobile device has a small database, and your mobile device runs on the Linux operating systems. It communicates with the remote, the database, which may be in cloud systems. Usually it goes and brings data through web servers. Database embedded in the mobile device is called SQLite, and the database, the frequently used because it is free on the cloud systems is MySQL. So a lot of data needs to be transmitted between your mobile apps and the cloud systems, the database. One of a typical example is there is a banking database, and you have an app for a specific bank account. There are two types of securities that can protect attack, or the attackers grab your mobile device to connect your banking systems as if he is you. So there is some access control maybe implemented in UI. So if it is not really you, then some of the app buttons may not be a click. When data is transmitted between your device and the banking systems, then data formatted in a specific data format, which is JSON. And this is an example that how the buttons be enabled or disabled depending upon the credentials of users. There's some example, some of the sniping and spoofing threats has been identified by National Institute of Science and Technology. So this is JSON-based communications between your mobile device and, for example, the banking system. And the sniffing attack may tap into your wireless communication, and therefore attackers can catch your login access and send that login access continually to the database. And from that time, when database replies to your request, then data comes into the attacker's device and may or may not be forwarded to you. That is not impossible. It's a lot of risk available. The traditional approach is to use a cryptograph. So your login ID and password is encrypted. And then data that your banking system sent to you, that is also encrypted. Encrypted data can be decrypted by using key. So if attacker intercept the key, then all the data can be sniffed and spoofed. So it doesn't guarantee the security in the data transmission between your device and the banking system. Our target is to look at the long duration transactions. For example, mortgage loan applications, then it takes long, right? So during that long process, if your key is intercepted, and then key may be continually used. The one that we used here, blockchain approach, is the data can be decomposed into multiple chunk of data pieces depending upon some of the sensitive data. So one data chunk may contain one sensitive data. For example, social security number maybe on this chunk, and then underwriter's ID is another chunk, and tax year and tax information is another chunk. These all together originally in one document. Okay, that one document can be decomposed into multiple others. That document's application may be in this the tree structure. What we want to do is that we send this data chunk. That is a one block, and this block is transmitted. And when the second block receives by the mobile device, then that second block is related with the first block. So, for example, if the first block is hacked, then when this guy received the second block, then immediately this device recognized that, hey, my previous block was compromised. So from that time, the attack is identified, and then it can be detected and then recovered, right? That type of things are possible. That is what we proposed here. The transactions, data communications is in this way. So initially, the web server send the first chunk of data to the iPhone apps, and then it gives back to acknowledgement, and then next chunk will be sent to, and then another acknowledgement, and another chunk. So it kept going that way. Therefore, eventually we can guarantee the long duration of transactions can be securely protected and securely transmitted. Thank you so much.